This is a video lecture PowerPoint on Chapter 1. Here is a list of some of the topics we will be covering within this chapter. Some of them will probably be review, but a lot of them may be brand new to you. The first thing we need to discuss is the scientific method. It is defined as a process used to solve a scientific problem. The steps include making observations and identifying the problem, creating a hypothesis. This hypothesis is a prediction, and it must be testable. Okay. Then you perform the experiment to test the hypothesis, analyze your data, and write a conclusion. This is a cyclic process that continues. Here are some additional key terms that are of importance. Please make sure you know these definitions. In addition to a theory being a well-established hypothesis, it also tells us why something is true. A law is a statement or fact that describes how something occurs. Matter is anything that has a mass and a volume. Volume can often just be defined as something that takes up space. And finally, the whole purpose of our class, chemistry, is the study of matter, the changes it undergoes, and the energy changes that accompany the process. Hopefully this is a slide mostly of review. A solid has a definite shape and definite volume. A liquid has just a definite volume, and a gas has neither. You can see from the photo, obviously, that this is the solid, this is a liquid, and this is a gas, because the molecules are very spread out. Other important things about matter. An element is something that cannot be changed into a simpler form of matter. These are found on our periodic table. A compound is a combination of two or more elements. For example, NaCl. A mixture is a combination of two or more pure substances. There are two types, homogeneous and heterogeneous. The prefix helps us know what the word means. Homogeneous means that it is uniform throughout, or the same. Heterogeneous means that it's not uniform or different. We also need to review properties and changes. Physical properties are things that can be observed or measured without changing composition. For example, the color of a substance or its density. A chemical property changes composition. For example, flammability. A physical change produces a difference in appearance, but does not change composition. For example, melting ice, it's still a form of water. Or ripping a piece of paper, it's still paper. Chemical changes are chemical reactions. That's when a chemical substance is converted into something that's brand new. For example, when we burn something, or when we digest it, because it changes. Please take a second to pause the video and complete these questions. Here are the answers. How'd you do? Hopefully well. The next portion of the chapter involves math and measurement. Measurement is defined as the quantity, dimensions, or extent of something, usually in comparison to a specific unit. All measurements have two parts, a number and a unit. A number without a unit tells us nothing. I could say 10. 10 what? 10 marbles? 10 pounds? 10 centimeters? There are two types of measurement, qualitative for quality and quantitative for quantity. Qualitative is description-based. Quantitative is using numbers. Please pause the video and identify what the examples are. The two that are underlined are quantitative examples, and the two that are not are qualitative. There are a couple of terms that are really helpful in determining how good our measurements are. They are accuracy and precision. If you are accurate, you are close to the actual or true value. For example, if the melting point is supposed to be 45.2 degrees Celsius and you get 45 degrees Celsius, you're accurate. Precision is how close results are to one another. I like to define precision as whether or not you are consistent. Do you consistently get the same value? The example below, 10.2, 10.3, and 10.4 meters, would represent the width of a classroom. Please sit there and think about whether these numbers are accurate or precise, both or neither, and pause the video as you do. Hopefully, you decided that these numbers are precise because they're close together. You can't tell if they're accurate or not because I didn't provide you with the true value. If I told you the actual value was 10.4, you would tell me that they were also accurate. But if I told you the actual value was really something like 15, you would tell me they were not. Let's move on and start talking about significant figures. Significant figures are all of the certain, definite digits plus one uncertain or estimated digit in a measurement. Here are the different rules for identifying significant figures. All non-zero digits are significant. For example, if I told you this, you would tell me that since none of those are zeros, you have 4 significant figures. Zeros between non-zero digits are significant. For example, if I gave you this number, you would tell me that that one has 5 significant figures. If a decimal is present, the zeros at the end of the number count, and if a decimal is absent, the zeros at the end of the number do not count. These are a little more confusing. For example, if I said this, okay, there are zeros both in front and behind the other numbers. Since the decimal is present, we say that the zeros at the end of the number count, which means that this number on are significant, and that would be 4 significant figures. If instead I gave you just this number, the decimal is not shown, so it's not present, it's absent, and therefore those zeros do not count. The only two numbers that do are these two, so this number would be 2 significant figures. Let's do some practice. Please pause the video and determine how many significant figures each of these numbers has. Now let's check your answers. My thought is the first 3 were probably okay. This one might have thrown you for a little bit of a loop, as well as this one. When we have a number in what's called scientific notation, the times 10, we pretend that times 10 portion is not there, and we focus only on the number. So that number has a decimal present, and therefore zeros at the end of the number count, which is why it's 3. The bottom one, we didn't do an example like that. There's a decimal, So zeros at the end of the number, both in front and behind the decimal, will count. And that's why it's 5. Now let's talk some calculations. There are some rules we have to follow when we are calculating in chemistry. If you are adding or subtracting, we're going to round our answer to the least number of decimal places. If we're multiplying or dividing, we're going to round our answer to the least number of actual significant figures. So when we add and subtract, we kind of ignore all the rules we've already learned. Let's do this example. So this first number here has one number after the decimal, so I like to label that 1dp. The second number has 2 decimal places, and the third has 3. You go through and you would do the actual calculation using a calculator, and you get 16.07. The least number of decimal places is 1. So your answer should be rounded to 1. To do that, I count over 1 space. I then look at the 7. That 7 changes that 0 to a 1. So my correct answer would be 16.1. For multiplying and dividing, I look at actual significant figures. So I go back to my rules. This number here has 2, where this has 4. So my answer should be to 2 sig figs. When I'm done, I go ahead, I do the calculation, and I get 356.86. But I only want 2 significant figures. So I go ahead and I count over 2. 1, 2. That 6 changes my 5 to a 6. And my answer becomes 360. I have to replace that 6 with a 0 as a placeholder because 36 and 360 are very different. Now it's your turn to give it a try. Please pause the video, complete the problems, and round them each to the correct number of significant figures. Here are the correct answers. Check to see how you did. The last one was kind of tricky because you had to put it in scientific notation since you only could have 2 sig figs. We're going to discuss that on the next slide. Scientific notation is using times 10 and powers of 10. Sometimes it's necessary to get the correct number of significant figures. For example, on the last slide, the answer we got was 300. Currently, that's only 1 significant figure. We need it to be 2. Well, if I put a decimal at the end, it's now 3. So instead, I have to put it into scientific notation, 3.0 times 10 to the second, to get it correct. You should be able to convert in and out of scientific notation from your math classes. When you move the decimal to the right, it has a negative exponent, and when you move the decimal to the left, it gets a positive exponent. Please pause the video and try the practice problems. Please check your answers. Hopefully you notice that the decimal is always after the first real number, and that if it's a small number, it has a negative exponent, and if it's a larger number, it has a positive exponent. The next part of the chapter involves the metric system. This is known as the universal language of scientists. Here are some of the base units. You will notice that none of them have prefixes. We are going to use this to convert.